Ladies and gentlemen, please welcome Senior Vice President, Security Products, Tom Korn.
Wow. Thank you. Welcome, everybody. Welcome to the session. I'm very, very excited about this session, which we've titled Goldilocks Zone, Security and Architectural Implications of the Software-Defined Data Center. This is such an important topic right now. It is, security issues are impacting our organizations, our businesses, our nations, our children's lives, our lives in such significant ways. It seems like a day doesn't go by that we're not reading about some new sizable breach. It's almost gotten to the point where we're numb to it. It's almost expected to see that in the news. And what I'm going to go through over the course of the next 50, 60 minutes is what exactly is the cause of some of these issues. And we're going to do it through a few lenses. One is through the lens of an attack. And we're going to take a look at what a modern attack looks like and why this is circumventing all these controls that we're placing throughout our infrastructure. And then we're going to look at it from another lens, which is what are some of the fundamental underlying architectural issues that are perhaps at the foundation of this problem. And then we're going to take a look at how virtualization might help here. Not so much how do we secure virtualization, but how can we use virtualization to secure our infrastructure. Now, a number of the product organizations have offered to pay me $20 to perform this presentation as a modern interpretive dance. And I say to you that is simply not taking this issue seriously enough. Okay. Need it. I have 50. You need at least a ballet for this. Okay. You look inside a modern data center, and what do you see? You see a series of layers of infrastructure: compute, network, storage. And on top layer, you have an application layer. And sandwiched in between, we have systems and infrastructure management. You can look at security through a very, very similar lens. We have security controls that we place on the compute infrastructure: antivirus, host intrusion prevention, process control. We have security that we place in the network, various forms of firewalls, IDS, IPS, advanced malware protection. We have encryption on things like storage. There is a set of security controls we're placing at the application layer: identity controls, authentication, authorization, federation, provisioning. And then there's a series of security controls we embed inside applications: application and database activity monitoring, tokenization, things like that. And there actually is, in my mind, a management layer for security in sort of two buckets, one being governance, risk, and compliance. How do we take the policies of our organization or regulations and map those to how we have to set up controls inside? And how do we, and then a security operations center piece of it, which is about technologies to provide us visibility to detect and to investigate and to respond to attacks that circumvent all this stuff that we place up here. We spent about $70 billion on this last year. $70 billion. About $27 billion in product, about $43 billion in services. That represented roughly an 11% growth over the previous year of spend, compared to an overall IT spend growth that was roughly flat. And that gap has existed not just in the last year, but for actually the last several years of record, where IT growth is often in the 4 to 5%, and security spend is in the, closer to the 7 to 8% growth. In fact, the only thing that's outgrowing security spend is security losses. Pat had mentioned this on the day one keynote. Brilliant slide that he prepared for that. This is really at the fundamental part of the issue. And it's not a lack of incredible products from very, very smart people in the security industry. Companies like Palo Alto Networks and Intel and Symantec and Trend and RSA, a whole host of companies, really smart folks who get it, who are building incredible products. It isn't a lack of funding. The VC community last year funded somewhere in the vicinity of 275 security startups last year alone. Okay? The spend overall from enterprises, this is not a spend issue. The premise of this talk is that this is fundamentally an architectural issue. And I don't mean that's the only problem, but at the base of it, there's an architectural issue, the way we have our data centers architect, that is inhibiting our ability to make significant leaps forward. And then take a look at that. What I want to do is start by taking a look through the lens of an attacker. Let's attack your organizations right now. Let's look at what a modern attack actually looks like, because wherever you are in the world, it's often you're the center of the map. And if you're dealing with firewalls, that's the center. And if you're AV, that's the center. But an attacker doesn't look at it that way. A modern attack, and what I'm doing here, is a sort of a modified kill chain. For those of you not familiar with a kill chain, this was an approach, I think, popularized by Lockheed Martin, that basically is, think of it as a series of steps or the process of a modern attack. And you use it to, or among other reasons, to take a look at how you would defend against various stages. A modern attack starts with human recon, about who are the right people to compromise inside the organization because they have access to the right things. And it's often not the CEO, it's often the admin. CEO often doesn't access anything. It's not the head of operations, it's the frontline guy who walks in and out of very secure areas and might bring with them removable media. And the best way to find those people is not by stealing an org chart, because I can't make heads or tails of our own org chart. It's by looking at LinkedIn and Facebook, where all of you are so kind enough to divulge all your responsibilities and the kinds of things that you would have access to in an organization. Based on that, I also have to produce an attack vector. I need some malware to produce that. Now, malware is, in fact, getting more and more sophisticated, but the weaponization of cyberspace has enabled us to produce malware with a lot less complexity involved. For between $5,000 and $6,000, I can buy the Zeus kit, which allows me to develop malware. Based on that, it comes with customer support. If I have issues, I can call in, I can email in. The black POS that was involved in a number of the retail issues, that's actually less. It's about $2,000 to $3,000, which I can purchase. Once I have the malware, I need a delivery mechanism. And that approach can be done through spear phishing. I can create emails to try to encourage you to open the things. We can use watering holes, which is by compromising things like school systems, utilities in local communities that have a lot of employees from a target organization. Very common right now is supply-side attacks. You go after a weak supplier, weak in terms of security, and then you're able to spoof communications from that or through their systems. I was actually at RSA during the RSA breach and lived through much of this, and there they compromised an HR contractor, and then were able to kind of come in through that piece. So these are the methods in which they deliver those pieces. You compromise an entry point, and you install essentially a command and control infrastructure, which is giving me the ability to have visibility inside your network and control of that. And what I start to do is first I'll probably deposit a couple of pieces for good measure, say strain A, strain B. I'm going to put B to sleep. I'm going to wake A up. I'm going to escalate privileges on that machine. And I start performing lateral movement, moving throughout your infrastructure. I bank on the fact that you have a hyper-connected computing base that allows me to hop from place to place inside. I continue to install command and control infrastructure, and I'm wiping everything. I'm turning off security controls on endpoints where necessary. I'm cleaning logs, wiping my tracks. At some point, you might catch me, and I'm totally cool with that. You catch me, and my command and control infrastructure gives me visibility into what alert I set off and how you wipe me from that machine. I then wake up B. I modify it not to set off the same kinds of alerts, not to get wiped in the same way. I install C or D, and I put that and lay that dormant for good measure. And this gives me persistence inside the attack. Then the hard part is I have to break into the data stores inside the data center. You'll often have better security on those, perhaps encryption. I've got to find the keys. I've got to parcel things, obfuscate it, wipe my tracks, exfiltrate it, and clean up. I can do this for weeks, months. There's been many cases this has gone on for years. It's not about a virus. It's not about a worm. It's not about attack on the perimeter. This is the way a modern attack looks. And when you take a step back at it, we spend most of our money and our effort and our resources. We often call it the perimeter. I would articulate it as our north-south boundary, where essentially most of our protections are aimed at stopping infiltration. And the sad news is you're already infiltrated. I would venture to guess there isn't an organization in this room that probably doesn't have some compromise, some malware on some systems. And I'm not suggesting there's some big organization doing an exfiltration on your network, but I am suggesting that it is just too easy to provide some way into an organization. The issue is we don't have the visibility and control inside our environments to be able to detect and respond and stop exfiltration. And that's where this goes. Ironically, we often hear about how this is asymmetric warfare. The attacker has to only win once, and we have to defend off every single one. But as you move through this chain, it actually becomes increasingly symmetric. They become increasingly exposed. But again, we don't really have defenses in that. Now, the security vendors and the leading security practitioners, they get this. And they're changing this from increasingly perimeter-centric to increasingly application and user-centric, because security attacks and defenses go to the edge. They go to the users and they go to the applications. They are moving increasingly from just inline prevention to analytics and out-of-band mitigation, because you have to look at this holistically to really see and make sense of an attack. And we're increasingly moving from simply managing compliance to managing risk. Compliance is important. But make no mistake about it, compliance is not security. And in fact, in many organizations, compliance drives the behavior about what is the least amount of things I need to do in order to not be culpable. And that is a very different task than trying to really manage risk and security. The issue here is not the security vendors or the security practitioners don't get it. There are architectural issues that are inhibiting our ability to address this issue, or more specifically, moving security inside. Security teams, it's not like they haven't heard the perimeter is gone. It's that it turns out to be really difficult to put security controls inside a data center. And there are architectural issues at play. The three main architectural issues are, one is what I call the logical segmentation issue. It's the inability to segment our environments at the right level of granularity around logical boundaries. And I'll explain all of these in a bit more detail in a minute. The second architectural issue is what I would call the compound policy problem. The fact that we can set up policy for individual controls, but we have struggled with being able to set policy across controls and operate them as a system. And the third issue is the context isolation trade-off. The fact that we don't have the right handles to implement the policies we're doing, and we don't have the right telemetry for the analytics that we're trying to perform. There's a common thread, interestingly enough, between these three pieces, and that common thread is the application. The ability to segment things around the application. The ability to align controls and policies around the thing we're trying to protect. The application, the ability to get context about the application. But we have no mechanism to kind of maintain the relationship between the application layer and the infrastructure layer. But interestingly enough, virtualization is a ubiquitous abstraction layer in our data centers today that actually has to maintain the relationship between the applications and the infrastructure. And in that, there's an opportunity to change this in really, really fundamental ways. So let's take a look at each of these in turn. The first, this logical segmentation problem. The issue is that our environments are a hyper-connected computing base, meaning virtually every computer is connected to every other computer. And we did this for very legitimate reasons, to facilitate organic growth, to make it easy to add and change applications inside a pretty complex network environment. But it creates two problems. One is it really facilitates lateral movement inside our environment, and it's easy to do, and it's easy to conceal. And the second issue is it creates incredibly complex policy for our controls that we place inside. Because we can segment things on the perimeter, or we can segment some physical zones, we can segment web tiers and database tiers, but in any one of those segments, we're going to commingle tens, hundreds, thousands of applications, and so the policies of those are going to be very, very complex. It's why when you place a firewall inside, you end up with 100,000 ACLs in it. And no one ever removes any of those policies, because it's like a game of Jenga. I don't know if I'm going to remove this one, if everything's going to kind of tumble down on me. This is really the issue. Now, the solution is the ability to segment around these logical contextual boundaries, the application, versus the perimeter or physical zones. But the obstacle is we have no mechanism that maintains the relationship between those two layers. So we could mentally reverse engineer this and segment it appropriately, but the moment the application changes, moves, scales up, the physical infrastructure changes, I got to redo it. That's the logical segmentation problem. Problem number 2, I'll call the compound policy problem. It's the ability to make sure I put the controls in the right place, in the right order, because order matters, right? See what happens when you put encryption before DLP? See what happens when you put a load balancer before a web application firewall and you can't resessionize the traffic? Order matters. And it's also the ability to share state, the ability for the policy of one to take into account the analytics of another. It's like imagine a football team where every player was the exact same position and they just all went after the ball. Compared to I have different people on that team who perform different things. They have a common goal. They can respond to changing conditions on the ground. They can communicate to each other, but it's a team. It's a system. It's the same thing here. Defense in depth wasn't supposed to mean I'm just going to throw a bunch of crap at it and hopefully one of them catches it. It was supposed to mean I create a system of a series of different controls, but these controls can align and work together. But the first problem I have when I try to move a bunch of controls inside is the compound policy issue, this complex distributed policy issue. If I imagine I put a series of firewalls inside a data center, and traffic moving between machine 1 and machine 2, depending on its route it picked, hits 4 or 5 of these firewalls. What's my firewall policy? My firewall policy is the policy of all the firewalls I hit in the order that I hit them. That very quickly becomes an intractably complex problem. All right, so here's a way to solve that. I'll make one really big control, and I'll route all my traffic through it. I'll hairpin through it. Well, first of all, we have yet to create a single control that can scale to handle all the traffic of a data center. And as soon as we start dividing that up into pieces, we start hitting back on the same problem. The shared state issue is very similar, which is the only way to get controls to align on policy and to be able to have one react to another is really twofold. One, you can complain to your vendor to go tell them to integrate better with the other sort of products, right? And that they have to do kind of one piece at a time. They can create APIs, but there's work to be done. And then there's another, which is to flow every piece of information up to a central analytics system to be able to perform it in the sky. Now, it's not to say that neither of those things aren't useful and important things to do, but they're not scalable to this kind of problem. We need a shared state mechanism. So what we need is a mechanism to insert and order controls on logical boundaries and to have it stay there wherever it moves. And we need a mechanism to be able to, for them to publish their state, what they see, what they think, so that other controls can respond to it. But we have no such mechanisms. We can insert on physical boundaries. We can share state through point-to-point integrations or by correlation. But neither of these things get us there. That's the second one. The third architectural problem is what I'll call the context isolation trade-off. You know, security really only can do 2 techniques. There's a policy technique and there's an analytics technique. And the policy technique says only these users are allowed to get access to these applications. These things are not allowed to connect to these things. Only these kinds of processes can occur. And there's another technique, which is the analytics technique, which is about finding anomalous behavior from what I normally see. Both of these techniques, turns out, really need to rely on much more logical constructs like users and applications and data. That is what our policies are based on. And from an analytics perspective, it turns out it's a lot harder to deterministically figure out sort of this is anomalous and meaningfully anomalous when you're dealing with the bits and bytes level as opposed to the logical level. But that's not really what we get inside a network. What we get inside a network are IP addresses and MAC addresses, and we use them as proxies for users. Or ports and protocols, and we use those as proxies for applications. And they were never great to begin with, but trust me, they're even lousier now, and in fact, we've probably made it worse. We can't rely on that. In fact, the whole advent of the next-gen firewall market is testament to this issue of saying we can't really operate purely on that kind of piece. The issue is that the only solution we have is to start putting agents on the endpoints themselves. That's a way to get context. If you put an agent on an endpoint, you actually can see the application stack, users, applications, data. The problem is we're inserting our controls inside the very same trusted domain as the attacker. It's right in the attack surface. What's the first thing the attacker does? They go, the attackers aren't trying to attack firewalls. It's so much easier to go in through the endpoint and the application. Once I'm down, I come in through the application, I go into the operating system. The first thing I do is I start compromising the security controls. So I can get context, but no isolation. I put it in the network, I can get isolation, but I can't get context, right? And I need both. It's not a trade-off I can make. So that's the context isolation problem. That's what I mean by there are fundamental architectures. Why can't we get ahead of this? Why can't our security controls start being far more effective at this game? Well, given the nature of these modern attacks, our inability to logically segment things, our inability to align these controls and policies across these controls, and the inability of our infrastructure to provide these security controls with the right kind of context and the right kind of handles for policy is really the biggest thing inhibiting making a substantial step forward. But imagine if we could segment things around compliance scopes and application boundaries and provision and order our controls align with this, and share context to and among our controls, man, we could change the game here. We could dramatically reduce the attack surface. Lateral movement would be far, far more difficult inside our environments. The policies of our controls would be far simpler. A firewall, in front of one application, is 30 rules, not 130,000, right? And we could improve the effectiveness of all these security controls. They would have better telemetry to perform analytics. They could perform much more granular policy. They could take into account what other controls are. And the premise I have for you, and I'm going to walk through this in a bit more detail, is that virtualization may well be the Goldilocks zone for security. The term Goldilocks zone was coined in the 1970s by NASA researchers. They were coming up with a model of sort of suggesting, like, how do you find habitable planets? And it was about, how do I manage things that are not too close or too far away from a sun, so the heat is just right, and not too large, not too small, so it's the right kind of gravitational pull. There was a Goldilocks zone that was right in between there. We think actually virtualization could be the Goldilocks zone for security. That implementing, placing these controls in the virtualization layer could be the optimal place to do it. But what does that look like? How do you even do that? Well, I'll tell you the approach that we've taken. And the approach that we have taken starts with building in some fundamental controls for isolation, segmentation, and access control. Right? So built into the hypervisor kernel, some very basic constructs to do this, to divide up and to leverage the fact that the hypervisor and the virtualization layer has some context between application and the physical infrastructure. So we can now get very, very granular about how we draw these boundaries, and we can draw them around logical constructs, and it will move as these constructs move throughout the physical infrastructure. Next, there are fantastic security products across all of these things, from folks like Palo Alto and Intel and Symantec and Trend and a whole host of companies that are all across this board. Now, how do we insert them into this environment? Well, we take virtualized versions of those, and we create something called a security VM. And we take an orchestration layer and provision those security VMs into our virtual environment, leveraging our segmentation, our isolation, these logical boundaries. And now we can say, you know, I've just created a data center with one critical application in it, and it has a north-south boundary, and it has some shared services, and it has some elements. Now I have all the context for the kinds of endpoint and the kinds of network controls that I need applied against that. I can update that content. It's going to be very, very, very focused. And then third, provide a mechanism to provide the context to those security controls so they can see not just events and logs and alerts and traffic, but what applications are these, what users are these, what data this is. And let me go very specifically into each of these and what it might look like. So this first one, just going back to these, by the way, these three boxes are kind of the three building blocks I think are the biggest disruptions coming out of that we're doing, I think, on the security front. Right? The one on the bottom right here is really what you've heard a lot about called microsegmentation and the distributed firewall. If you've heard anything about that, there's a bunch of sessions and great white papers on it. And the one on the bottom left, you may have heard, there's a lot of articles and papers on the Goldilocks zone. That's really dealing with that. And this blue box on top, there are some products called Service Composer. And there's a bunch of sessions, I think, going on about that and some of the orchestration layer. But let's take these one at a time. In microsegmentation, in my network, I might have a series of tiers, I have shared services, and my ability to then start thinking about these as I have applications, they have elements from all of these, and I can draw boundaries, not just around physical zones or tiers, but also around these logical places. And around those things, I can have full isolation. These things cannot talk to each other. They don't even know the other. They're in entirely different network address spaces. If you were sitting inside, you couldn't scan for them. In fact, they might share all the same IP addresses. They're completely isolated. In fact, that's the default. You set up segments or networks, they're by default isolation. Then you can set up explicit allows to connect these things to. Then you could provision security controls to have a secure communication path and order them in the right order. You can even have structured secure communications paths where you can place controls around the right boundaries structured in the right order. This is the power of microsegmentation. It's really one of the foundations here. It's a fundamental building block that sort of says we can simplify this in a huge way by starting to create some boundaries in the right logical way. Yes, we've been able to segment before. We haven't been able to segment like this before. The second major one, advanced context. You start with a server and you put a hypervisor on it and you put a series of guest VMs on it, and the way we got context before is we put agents on each of these. Problem is that we have no isolation on those agents. So get rid of those agents, and instead, what we did, as I mentioned earlier, we built a series of isolation, segmentation, and access control mechanisms into the hypervisor kernel. The distributed firewall, all the mechanisms for microsegmentation. And then we work with all of the security vendors who are building fantastic products of all different kinds. And we enable them to exist in this environment as a virtualized version of themselves, but not just a virtualized version of themselves, but a security VM. And a security VM can sit in the same hypervisor as the guest VMs, but they are completely isolated in network and compute address space. They're on different networks, so we can maintain sort of isolation. The security VMs, and of course, what we're putting in the kernel, complete isolation. So where's the context? We put a piece of code that's running inside the hypervisor that can exist inside each of the guest VMs that can pull that context, just like you would have if you had an agent sitting in the OS looking up the stack, but completely isolated. We have a series of mechanisms to isolate it both in address and memory and CPU space, so that we can, the model is, let's completely compromise that guest VM. Let's flood it with malware and still maintain the integrity of that piece and create a secure communication channel between that and the security VMs and, of course, our own piece. Now all of those things can use that context. They can create policies based on application or user or data. They can see these. They can do analytics based on it. That's the magic. It's really cool stuff. Okay. That way, we now don't have to do this trade-off. And the last architectural issue is the policy orchestration. So as you can see from the previous examples, you can kind of get an idea of how you can take these security VMs and you can provision them in the right place and even in the right order. The last thing we really haven't talked about is sharing state. How can they share state? Which is something we've always done through sort of point-to-point integrations. The way you do it is you create an externalized state distribution mechanism. We actually do something and we call it tagging, which allows any control, security control, to publish, write, read, remove these tags. And it's a way for them to communicate state. And here's how it might work. A policy might be that I have advanced malware agents and protection on all of my endpoints. And I want, if I spot something that's suspicious, I want to be able to go to DEFCON 1, where a series of things are going to happen, like I want to escalate my gateway authentication from 1 to 2-factor, and I want to ratchet back some access controls so that fewer things are allowed in and out, and I want to increase logging so that I'll have much more visibility to do any kind of forensics on it. And the ability to do, the way this would work is my advanced malware control, anyone who's doing advanced malware analysis, can be put in there, and they have the ability not only to spot it, but to tag it. Now, any other control can now see that, and they can factor that into their policies. Or more aptly, you could use those two things together to be able to set those and to coordinate on those and to do those, and then once it's dealt with, to be able to respond, to move that back and to move those pieces. Very, very, very powerful stuff. So, I have a very special guest, and yes, you did just see that amazing animation. Richard Soletto is the head security architect at Westjet Airlines. Now, you've just heard me talk a great deal about how this might all work and why this is all meaningful. But I think it's very, very interesting to talk to someone who actually did this and has been implementing this at a major organization. So please allow me to welcome to the stage Richard Soletto.
Thank you, Tom.
Welcome. Did you like my animation?
I did. It was a perfect landing.
A little turbulent, but... We've been talking about this for the last few days. Tell us a little bit about Westjet Airlines and what you were trying to do that kicked off this whole project. Because there was a bunch of thinking that went on long before you ever looked at virtualization or software-defined data centers. So just give us the context on that.
Absolutely. We started off trying to solve a problem of manageability and performance, or at least that's what we believed the problem to be. We have a very traditional network with DMZs and internal network, and we added secured internal zones into that equation. And then compliancy came along, and we started even splitting those up more. And we started seeing problems with performance and complexity in the network and really not having that manageability. The interesting thing is, as we dived more into it, we came to the realization that security was the problem. And how we implemented that security was actually what was causing these manageability and performance issues.
Yeah. So now you had looked at a few ways of doing this, because before you knew that the software-defined data center and some of these pieces could do that, you looked at other approaches, correct?
Absolutely. When we looked at trying to solve that security problem, we looked to John Kinder-Vaug's Zero Trust model, which is an excellent model. And we started looking at how do we implement that model inside of a data center. And we started by looking at Big Iron as a solution to that. But Big Iron really brought a lot of other complexities along with it. You know, you're basically taking a firewall and making it a core grade firewall. That means you've got a lot of physical elements that you need to deal with and make sure that they're resilient to it. Not only that, but when you talk about the service insertion, about putting in things like web application firewalls and IPSs and whatnot, now you've got to get those devices into the core as well, and the complexity that all comes around with all that.
Yeah.
And then there's the price tag. It wasn't.
Which, I think you had mentioned that it would have been extremely expensive to try to do purely in hardware.
Absolutely.
And by the way, for those of you not familiar with the Zero Trust model, or sometimes referred to the principle of least privilege, the idea is that rather than having everything connected and then we'll work on the back end to figure out good from bad, we start by looking and creating, for an application, for example, what does it need? And that's what it gets access to, and that's it. Right?
Exactly.
But in order to do that, the principle on that is privilege. Like, I have to figure out what those privileges are, and it becomes very difficult to do that in an open, sort of everything hyper-connected base. Right?
Absolutely.
So, you saw a bit about the software-defined data center, and that kind of clicked with how you could connect the dots together. Tell us a little bit about the project and what you're doing. Like, how are you starting, and where are you focusing on this?
Well, when we started doing the research on SDN. And how those could solve those problems, and it's the advantages there are really that the security and the network is really baked in together, but yet still somewhat decoupled. So how we started our process towards that? Really how we started the process towards that, we approached VMware, and VMware told us about the NSX product. And we had looked at other SDN solutions, but the advantages that we saw with the NSX solution is very baked into the hypervisor. So we had that distributed firewall and the distributed routing, which really solves the performance issue, because we can now do optimal routing in terms of directing traffic around inside, keeping it in the hypervisor if that's our choice. So we went into the lab, and we did work in the lab and experimented with this. And then now we're into production and implementing in our production. But probably the biggest step that helped us along the way is having a good security model to work from. And we really spent time and came up with a good security architecture model. And that model, the really cool part was that model implemented very easily and had really good visibility when we put it inside Security Composer. Service Composer.
By the way, I speak Canadian, so process means process, in case you know.
And it is Z.
Exactly. So one of the questions I often get from customers looking at this is like, where do I start? Like the whole premise of segmenting things around applications, the most common thing is, it's a mess in there. Like if you were, great that you've given me this ability to do that, but it's not like we have a map of where all our applications are, what applications we have, how they're connected to. This seems like super complex to try to figure all of that out, and then to map it all out, and then to virtualize the network. How did you get over that hurdle? Was that ever a concern, and how did you get through that?
It's interesting because it was originally a very daunting task to think about how we were going to come up with a security architecture model and how we were going to implement it and whatnot. And we looked at various models. Like we looked at it based on compliancy, data classifications, and those all become very complex, and the firewall rules are complex. So taking a look at your data center from a service perspective, which is getting increasingly easier as we move to SOA architecture. So what you're really doing is take a look at your data center from that perspective and start to understand those services. And probably your application owners and your infrastructure support people understand the concept of that service. So take a look at your data center from a service perspective and start defining those boundaries based on that. Don't think about it from a network context, because that's the beauty of service composers. You don't have to look at it from a network context anymore. You can simply look at it as a collection of workloads that make up a service. So definitely do that. Definitely get into the lab and start playing with it, with NSX inside your lab, and start, if you haven't already, start playing with it, because there is a bit of a fear factor you're going to have to overcome. Yeah. And getting people through that process is really important.
Yeah, so it's funny. This seems to be a common thread. Interestingly enough, network virtualization has two major sort of use cases. One is sort of cloud automation and provisioning, and the other really is security around these kinds of things. And interestingly enough, right now, this is among the biggest drivers of what people are sort of adopting with. They get the network provisioning, they get that sort of cloud automation piece, and that's where they want to go long term. But this gives them a very tangible use case to deliver some value, to solve an issue. And to your point, Richard, you don't need to boil the ocean. You can start even by looking at a single application, but it does start by conversations not about technology, but about what the policies are and what are you trying to protect, I guess is kind of what you're saying.
Absolutely.
Great. Well, terrific. Thank you so much.
Oh, my pleasure.
Really appreciate it. We're gonna open it up for questions afterwards, but thank you. Okay. So I'm gonna make a few closing comments, and I know we have plenty of time. We tried to leave plenty of time for questions in case there are any. We've had a series of successive waves. We've talked so much about these. The first wave being the mainframe era, where we were dealing with millions of users and thousands of apps, and then we moved to this client server, and we were dealing with hundreds of millions of users and tens of thousands of apps, and we're now moving to this wave where we're dealing on an order of magnitude bigger. If we think we don't solve these fundamental issues of being able to look at things through logical constructs, this stuff is going to get worse. But the flip side of that is this is a huge opportunity. Because in the previous two waves, security was a bit of an afterthought. As security practitioners and technologists, we didn't have the opportunity in the previous ways to get brought in right at the upfront of how we were architecting this. We have that now. That is a great deal of where the thought is kind of going to. And the key is that we have to seize this. Virtualization is getting us an opportunity to think about the foundation, the architecture. If you don't have the right foundation, you can keep patching cracks and you can keep building more stories on the house, but it's very, very difficult to sort of catch up on that. And it giving us the ability to create a foundation to really start doing security in the way that really it should be done. Then the call to action for practitioners, for the security teams, is to take advantage and seize this. Right? Get in on the ground floor of these pieces. Don't look at this as simply, this is one more thing I need to secure. But ask the question, how can I leverage this to secure the things that are most critical to the organization? And to the security vendors, it's a very similar call to action. You need to get smart about this and start looking at how you're going to take advantage, not just as yet another platform to plug into to be able to operate on another new environment, like some new operating system or some new networking protocol, but rather how can I take this to do fundamentally disruptive things in my security category? What if my control could be everywhere? It could be ubiquitous. What if I could have context about applications and users and data, and I could do things on that. I could operate on that sort of dimension. What if my position could be protected and isolated from the attack surface? Right? What if I could share state with other security controls and integrate with an ecosystem of mine without having to do heavy engineering lifting every time I was trying to integrate with another security product? That is the opportunity. It is a once-in-a-wave opportunity for this to get in on the ground floor. It is an area we're making a very, very big investment. We are taking very, very seriously. And our mission is to become not a security company. We're not a security company, we won't be a security company, but we may well become the most important company in security by starting to address these architectural issues, these foundation issues that allow us to address this in the way it really needs to be addressed. So, I thank you all. I hope this was very helpful. And I'd be happy to open the floor if there are any questions for either myself or for Richard, or if they're very hard questions. Thank you. I do musical numbers. Yes. There's actually a microphone right beside you, just behind you there.
So thanks for the presentation. Can you illustrate for us what functionality comes out of the box with NSX versus what other functionality would be provided by some sort of a virtual firewall inside the hypervisor? Because it seems like simple ingress and egress rules can be implemented just using NSX itself. Yeah,
so I'm just going to go back to this diagram, that we had just here. And on this diagram, just built into NSX, the bottom right box, there are all these built-in controls for microsegmentation. There's the distributed firewall. All of those things, all of those mechanisms exist and actually just come with NSX. In the right-hand side, where it says context and security telemetry, there's a variety of telemetry that today that is passed over, largely consumed by endpoint security controls. So you'll see vulnerability management systems or AV vendors taking advantage of some of this and using some of that context. And the blue box on the top actually is implemented today in a product called Service Composer that again comes with part of NSX. All of these things are just part of NSX. They're all these constructs. So all of that can happen today. And the use cases that people are, the main one that people are doing is around microsegmentation, or more broadly, I'd say it's about reducing the attack surface. How do I create these boundaries, these logical boundaries? How can I create segmentation? So I have isolation around it, and I have only a couple of egress points. How do I deploy some of these security controls on those boundaries and inside? And how do some of those take advantage of context? All of that exists today. All of that comes out of context. In terms of what's coming and what's future are advancements in each of those three boxes, right? There are going to be other things we do to create isolation layers on the isolation pieces. On the context piece, we're doing a lot of work on creating very hard, and we have some really innovative techniques for isolation around that piece, and to be able to pass that context more effectively to network controls to consume. And then on the orchestration layer, there's a whole bunch of things that we're going to be doing and innovating around the tagging mechanisms. Right? Today, a lot of the tagging is VM-centric. There's a lot of things that we're going to do to tag traffic. There's pieces that we're going to do to create secure, trusted tags that can't be modified, which will help tremendously with compliance and independent verification. So there are, over the course of the next 18 months, there's actually engineering work happening in all three of those boxes. But today, there's already pretty significant pieces, and then there are a whole variety of partners in the layer above that are already working this, both network and endpoint vendors. Was there another question? Yes, sir.
Yes. Could you elaborate a little bit more on tagging as it relates to existing tools that are deployed by certain teams like Mandiant agents, Palo Alto, Centripetal Networks, a lot of organizations that have already deployed many of these tools that are just in the millions of dollars. How do you leverage those tools to expose tags from those tools and then get them imported into vCenter so they can be orchestrated?
All right, so that's an interesting question. The tagging mechanisms today are largely inside sort of the virtualization layer as opposed to on the physical layer. So today, the way it functions is you're essentially tagging at the VM level. And what happens is that any security product that, that integrates with the APIs into NSX, there's a series of VMware APIs, one called NetX, which allows them to insert in the data path, one called EPSec, which allows them to connect to the endpoint in the context, and then there's an API for them to plug in. So there's essentially an API for these three boxes, and that allows them to essentially register with the top layer, Service Composer. That gives them the ability out from the outset to be able to write tags, read tags, etc. So Palo Alto has done integrations like this. They can read and write tags to that layer. Intel is doing work here. Symantec, in fact, there's a bunch of demonstrations on the floor by a lot of these companies, Trend, that have pieces to be able to do that. In terms of something that isn't virtualized, that is purely in the physical network, being able to interact with tags, I am not aware of the ability to do that today, but I know there are some folks in the audience that I see Jim Weesey, who runs the engineering on a lot of this, nodding his head. It's all good to have. He's my lifeline. I'm going to call you, Jim. You're going to be my lifeline.
So for folks that are, have been doing these solutions before and so forth, just to capitalize on the comment there, we've actually worked with a lot of the key vendors to be able to publish these mechanisms. And probably the key use case I'll describe that's currently implemented that Tom's referencing is the ability to do things like whether a virus is detected or the CVSS score by a vulnerability management solution gets reported up in the infrastructure. And when that's reported up, the really key piece there, we've done a demonstration, I think the Rapid7's got a demonstration of this, as well as a couple of other vendors, where it'll actually say, hey, if I see that the CVSS score is high, we will actually impose a firewall policy around it because we see the actual firewalling there. This would be similar to normally what would have historically been done in CMDBs or where the updates got there. What we're trying to do is that, as you well know, trying to script around all the CMDB updates and then making a lot of the VMware customers basically roll their own stitching solution every time. We're trying to be the platform that a lot of the vendors come to. So there's some augmentation that's currently needed for vendors who haven't done the integrations with us. But as Tom had mentioned, Trend, Symantec, Rapid7, we've got a long list of vendors that have started on this journey with us. And we're going to be continuing to quite a bit do as much as we can to facilitate a lot of that bridging. So you'll see some things coming out from us later on in the year as well around this area. But for now, you actually do have the ability, if there isn't an integration, that you actually can come through a REST API into the management system, and then you can actually manually push tags. So if you want a VCO workflow to read from something and then post in, you actually can stitch that together if it's a more of the legacy style solution as well. But does that answer your question?
Absolutely.
Yeah, fantastic.
Great, thank you, Jim. Yes?
This sounds great regarding virtualization and everything, but I'm sure there's a lot of companies like mine out there that still has some legacy applications or traditional monolithic servers, like database servers, that are still running on monolithic hardware.
Yeah.
I've heard references already this week about NSX working with that in some ways, but haven't heard a lot of details. Can you elaborate on what's being done?
Yeah, it's funny. This is another very, very common question that comes up. And actually, a bunch of us were talking about this. I don't know, Dennis, if you want to elaborate on some of the pieces or about how we're leveraging some of the physical infrastructure. Dennis Moreau is the CTO for security inside VMware.
So we are doing an awful lot to align with the exterior edge to be able to define what are the constraints out there, the centralized components that aren't within the software-defined data center, and to expose those constraints so that we can manage knowing those, leveraging them, and maintaining the competitivity across the dynamics that exist within the software-defined data center. So very normal use case, not something we're walking away from. In fact, something that we're going to expose increasingly as we become more and more aware within the software-defined data center, the policies, mechanisms, and configurations that are external, that represent essentially dynamics. Does that make sense? Is that responsible?
Yeah. Yes. Yeah. Oh, please. Yeah. Actually, funny. I should have asked whether you dealt with the same issue.
Yeah. I'll grab them.
Now you're on.
There we are. Awesome. Thank you, guys. L2, bringing hardware devices into the virtual space was a really big thing that drew us towards SDN and NSX. And the reason for that is when you start to look at Forrester's model of the zero trust model, it's based on service segmentation. Well, if you create a boundary and that boundary has virtual and physical workloads in it, then you need to be able to encompass both of those together. So there is a challenge with L2 bridging and security together, but it's fundamental to how that model needs to be able to behave. And we are working with vendors, VMware included, and starting to come up with some creative ways on how we can do that. We've found, just with the product out of the box, there are mechanisms to be able to do that. But we're seeing a ton, like as a customer, we're seeing a ton of interest from the vendors on being able to solve that problem of bringing virtual and physical workloads together. And to me, that was the big game changer. Being able to bring physical workloads into the virtual environment is a big game changer.
Yeah, makes sense. I don't know if we probably have time for maybe one more question. Yes.
So I have a question about how do you deal, or I understand how the virtualization provides you access to the context and the natural logical segmentation, but how do you deal with the problem of the malware coming in and attacking the security services and turning them off? It's not obvious to me how virtualization deals with that any better than just the standard concepts that are done today.
Yeah, the issue today, if you're putting a security control on the network, on the wire, you have a degree of isolation, right? It's not perfect isolation, and any of these things have exposure, but it's a much, much smaller attack surface than when you put an agent on the endpoint. The issue on the endpoint, yes, you can do a whole series of techniques to try to harden that agent, to protect that agent, but at the end of the day, it's actually sitting in the same trust domain. It's on the same network, it's in the same memory space, it's on the same CPU processing power. So the security VMs and the pieces that we're putting in the kernel are completely different. One, they're different network address spaces. We keep them on separate networks. And even the piece of technology that we've been building in to be able to pull the context, we essentially, in the hypervisor, have, among other things, we're essentially controlling both memory and the CPU. We have to in order to sort of operate on that. And we can provide some mechanisms and techniques to ensure that these two components are not in the same memory space and in the CPU at the same time, that we can maintain isolation across this. If you want a more detailed explanation on this, please stay behind. Happy to share with you, and there are some folks who can go into it in much more detail. But it would start, but there's the key piece of it. Now, is it perfect isolation? No, there is no perfect. Put a box on the wire. The only way to physically isolate these things is never connect the two things together. But we believe that we can shrink the attack surface down to be almost the same as putting a box on the wire. That we're talking about a very small piece of code and really control that memory space. Sort of the short answer. All right, guys, thank you so much. Really appreciate you coming. Hope it was helpful. Have a great rest of the show.